Hello everyone, welcome back to the session 8 of the current series of ML algorithms coding. In this session particularly, we will be starting off with the coding of different types of neural networks. To start off with, we will first see Perceptron, which is you can say a single layer or one of the easiest or the basic component of how a neural network is built. So let's see how we can build it, and based on that we will build much more complex things, feed forward, softmax, convolutional, and forward. So basically, so before I try to explain you this thing, I'll just explain the perceptron is type of a linear classification algorithm used to classify data into two categories. It's a simple algorithm. We are talking about single layer perceptron. So this is a simple algorithm that learns from mistakes made during the classification process and then particularly adjusting weights of input features to improve the accuracy of the classification. So for example, if you want to say, we can see something like this thing as a perceptron, where what we are doing is where we are taking the inputs x1 to xn and then passing on to multiplying them via the weights that we have or the biases that we have, then have the weighted sum. On that weighted sum, have some particular step function, and based on that gives an output. And if you're understanding of how a neural network works, you will realize a neural network is nothing but a combination of a lot of perceptrons and then other parameters, other biases, just constructed in a much more complex way. But the basic component of a neural network is what you can understand a perceptron is. And I'll say it's much more easy. Just there are two things that you need to maybe understand or think about is when we are doing it in this particularly, even in this thing, when we are trying to find the weighted sum, how we will find is the weighted sum for from this thing would be w1 x1 plus w2 x2 plus until wn xn. So that's what something that's written here. So we generally add the bias term or whatever weighted zero was there, and other than that, like w1 x1 plus w2 x2 plus wn xn. So here I think particularly I will see further, but I think here we are not using any step function in the end. And then the second thing is the weight, ith weight that is equal to, in the initial times, we'll maybe initialize it with zero or something random. However, with time, the weights will update such that the weight I equals to weight I plus learning rate into the target that we have and the predicted value of y that we predicted into x of I. So nothing but what we are saying is if we have predicted some particular weight for this particular variable, we'll in the next term we'll update it by the initial value plus learning rate into the output, uh, correct output minus the predicted output into the xi. So basically, let's start understanding how the coding implementation of this particular perceptron works. So in this particularly, we are making a perceptron class in which we are initializing the learning rate and number of iterations. And we will keep on updating the weights until so there are 2 points until either we converge or either we reach the number of iterations. Where in this particular case, we will run it until we reach number of iterations equals to 100. So in this, we define a fit function in which we are saying the initial weights are 0 and the errors, we do not have any errors in the beginning. So then we are running the loop for number of iterations that we have, that is equal to 100. And then here we have initially defined the error that we have is 0. So what we are saying for the xi and the target that we have, and zip is nothing but it's in a way we are using to combine different components. And here, if we have combined that thing, so what we are saying is update equals to learning rate into target minus predicted of xi. And then here nothing but we are doing something like this. This thing we are finding how much should we update. So for update, we are trying to find a learning rate into target minus y prediction. So that's what we have done here. So for when we want to update the weights for the layer one, the neuron one, what we are doing is we are multiplying it by xi. And in case if we have this particular weight, we are not multiplying it by the xi, or maybe we are multiplying, but the xi in this case is 1. So that's what we are. That's the reason why we just updated by the update. And then finally, we are adding all the errors to see if errors are there. And then finally, net input, we are just having the inputs here, and input XR, we are just saying like just classify based on how the inputs are, where a perceptron is predicting. So in this particularly, it says init initializes the perceptron and learning rate and number of iterations during the training. The fit trains the perceptron on input data X and Y. This method initializes the weight to 0 and iterates through the data and iterations, adjusting weights after each misclassification. And then net input, it computes the weighted sum of inputs and biases, predicts the class level for a given X. I mean, this is self-explanatory. So we have given X, we have given Y, and then based on that, we created an instance of perceptron. Then from perceptron, we are fitting perceptron on the X and Y. And then finally, there, we have got some new X, and we are trying to predict the values or the new values. So for example, we have 5,2. Generally, it should be something similar to this thing. No, it's not something like that. And for this thing, it's yeah. So I think that's what was a simple understanding of perceptron. I think just to understand what really happened is just understand what's there in this figure and then particularly try to write code according to that. And I hope you really liked and understood the concept of perceptron and you're able to understand how we can implement a simple one neuron perceptron. In case if you have any doubts, please do let me know in the comment section. And happy learning. Let's meet at the next session. Thank you.